All right, so now that we've spent some time learning how to solve equations, we're going to go off a little bit and take a look at something else. We're going to take a look at equations that have special solutions. Yes, that's the title of these notes, equations that have special solutions. Before I give you a couple examples, I want to go over some vocab that we've gone over in the past, but it's going to be super helpful for today. So first off, what is an equation? Well, that is a math sentence that has what with it? That's with an equal sign. So an equation is a math sentence with an equal sign. And the more important definition that I want to look at today is, what is a solution? Now, we've talked about it a bunch, and today it's going to be super important to understand this. It's the number, or a number, that you plug in to make the sentence true. Okay, so a solution is a number that you plug in to make the sentence true. So that's going to be big today because we're going to look at ones that have special solutions. So let me give you an example, and then we can take a look at what I mean by these special solutions. So the first example that I want us to look at is 11 plus 3x minus 7 is equal to 6x plus 5 minus 3x. So just like we've been doing throughout this whole entire chapter, we're going to use our strategies to solve this. We're first going to drop our line down, or our mirror down, and then we're going to simplify both sides first before I can do anything else. So taking a look at the left side of this equation, I have that 11 and that negative 7 that can go together. So that is 4. So I'm going to drop down to 3x. Taking a look at the right side, I can put those two sets of x's together. So I end up getting 3x plus 5. All right. So last notes, we practiced this a lot. After we simplify, the next step is getting all variables to one side. So are all the variables on one side of that line or no? Obviously not. Here's the line. There's x's over here and over here. So let's get them all to one side. Now, typically, we'd look at the smaller one and try to move that. Unfortunately, today this is a little bit weird. They're both the same size. So why don't I just move one of them and see what ends up happening? So how do I get rid of this plus 3x? I'm going to minus 3x. And if I minus 3x on that side, I'm going to minus 3x's on this side. So now that I do that, on the left, I end up having 4 plus nothing, which is 4. And 3x minus 3x, which is 0. On the right side, I have 3x minus 3x again, which again is 0. Because if you have 3 of something and you take those 3 away, you have 0 of that thing. If you want to say something with an x, or if you have 3 x boxes and you lose all 3 of those x boxes, you don't have an x box left, you just have 0. And then 5 is left over. So now, here's what we have. We have 4 is equal to 5. That's sort of weird. That's weird because, first off, we don't have an x at the end like we typically would, and 4 is not equal to 5. So this is why it has a special answer. Its answer actually is a bunch of words. So whenever you see this, I want you to write, there is no solution. Now I'm going to explain what that means here. So whenever you get rid of all your x's and one side says a number and another side says a different number, you're going to say there is no solution. Now what that means, if we go back to our definition of what a solution is, back at this, it's a number that you plug in to make the sentence true. So if I have no solution, that means that I have no number that you can plug in to make the sentence true. So that means if I tried to plug in 2 up here and this, it would not work. If I tried to plug in 3 or 4 or 5 or any number at all, none of them are going to work. And what I mean by plugging in, just to give us a little review, I'm going to plug 2 in here because my x is 2. Plug 2 in here. This side is 6 and this side is 6. That's why that is the solution. Here, there is no number I can do that with. So there's nothing that x is ever going to equal. So you need to say there is no solution. All right, let's do another example together that's sort of similar to that. Just so you guys see what's going on, because I'm sure that's a little bit strange. And I'm having 2x plus 6 plus 3x equals 5x plus 10. All right, so again, let's draw our line down to separate both sides. I'm going to take a look at the left, and I'm going to combine these two different sets of x's and end up getting 5x plus 6. And on the right, 5x plus 10. Some of you might notice why this is going to have a weird answer right away. Because in this step, when I try to get rid of the x's, they have the same on both sides. So I'm going to subtract 5x's from both sides. I still want you to show that step, and you'll understand why once we start doing inequalities. And we're going to drop 6 down is equal to 10. Again, there's no x's left. And again, it's not the same number on both sides. So here, we're going to say there is no solution. And that's it. Now that's not the only weird thing we're going to look at today. There's going to be one other type of equation, and I'm going to give you this last example, and then I'm going to have you guys try a couple on your own. So this next example, example 3, has a different type of answer. And let's take a look at it together. 6x plus 5 minus 2x equals 4 plus 4x plus 1. All right. So let's take a look at this random example together. I'm going to draw my line down like I have been the whole time, and now I'm going to get rid of some stuff, or I'm going to simplify some things. So on the left side, I'm going to simplify the 6x and the minus 2x, and that gives us the 4x plus 5. And on the right, I'm going to put the 4x down because I can put this 4 and 1 together and end up getting 5 again. Right away, some bells should be going off. You have the same exact thing on both sides. But let's do this next step that we've been doing the whole time and get all the variables to one side, or try to get all the variables to one side. Let's minus 4x from right here and minus 4x from right here. And I end up getting 5 is 5. How is this different from the last two examples that we looked at? So let's take a look at this one, and this one. How is this different? Well, hopefully you're noticing that it says 5 is equal to 5, and that is true. So when it is the same thing on both sides, it's actually not, there is no solution. It's all numbers are a solution, or there are infinitely many solutions. A lot of teachers say it differently. I'm going to say all numbers are a solution. And what that means, if you go back to our definition of a solution, that means a number that you could plug in to make the sentence true. That means that you should be able to plug in any number, or all numbers, like 1/2, or 2, or 0, or 5. In fact, I'm going to plug in 2 of them just to show you guys what I mean. So on the next page, I'm going to rewrite this and plug in for just some different examples. Feel free to write this or not if you don't really want to. I'm going to try, I don't know, what's a really, really easy x. Let's do 0, and let's do 5. I just picked 2 random numbers. You can really try any other one that you'd like to as well. But again, all I'm going to do is I'm going to replace this x with 0, see if that works, and then afterwards I'm going to replace it with 5 and see if that works. So I'm going to go 6 parentheses 0 plus 5 minus 2 parentheses 0, because of that right there and that right there. Same thing on this side, 4 plus 4 parentheses 0 plus 1. So this says 0 plus 5 minus 0 is equal to 4 plus 0 plus 1. Now, I'm pretty sure I don't need to clean that up. The left side says 5 and the right side says 5. So I know that 0 works. So that's a solution, just like when we checked that this one right here, the 3x equals 6, and we plugged in 2 and both sides were 6. The same exact thing happened here. Both sides were equal to the same. All right, so now that I have that, let's try 5 to see that it actually happens again. So instead of rewriting everything, I'm just going to rewrite the zeros. And I'm going to plug in, instead, 5s. 6 times 5 is 30, plus 5, minus 10 is equal to 4, plus 20, plus 1. All right, this might be a little bit tougher. The right one's really easy. 4 plus 20 plus 1 is 25. And here, 30 plus 5 is 35, minus 10 is 25. So both sides, again, are equal to 25. So x equals 5 works as well. I guarantee if you try every single one, they will all work. So the big thing I want us to write, or the rest of these notes, or the words that I want us to write here, is the two different cases we have. First one is when the numbers are equal to each other. Okay, that's actually the second thing that we looked at today. The answer to that is all numbers are a solution. And the example that we had today is when it said 5 is equal to 5. Now the first case that we looked at today is when, oh, I should put the 2, is when the numbers are not equal. And that's, there is no solution. And that was the first case that we looked at today, when it said something along the lines of 4 is equal to 5. Now that's not going to be the only one. It could be any number is equal to any other number. That's not the case, so because of that, there is no solution. All right, I'd like you guys to try one for me, so I'm going to write it up here. You try it, and then we can see if we did it correctly. So I got 2f plus 3 plus 4f is equal to 6 plus 6f. All right, so pause the video, try it, unpause it when you think you have it. All right, so hopefully that was enough time. I'm going to draw my line down. I'm going to distribute on this side. 2f plus 2 times 3 is 6, plus 4f. 2f and 4f give us 6f plus 6. And then on the other side, I already have 6 plus 6f. If I try to get all my variables to one side, I'm going to subtract 6f's. And I end up getting 6 is 6. So if I go back to my list that I just said here, when it's the same on both sides, like this one right here, it's this first case, and all numbers are a solution. So I'm going to say that down below here. If you do not actually say the words, you don't get full credit. All numbers are a solution. And that's it, guys. Thank you so much for watching this video on equations with special answers.